Okay, good morning everyone. Our workshop for today is about exponential functions. The first objective is that I can determine and represent the domain and range of exponential functions using inequality. So let us begin with some problems. Okay, so the first problem is the graph below shows the exponential function and then use the graph to determine the domain and range. So let's begin. So the domain for this one is a set of all real numbers, and let's explain why. There's an arrow to the left and there's an arrow to the right, and whenever there's an arrow to the left and to the right, it is set of all real numbers. So the domain again is set of all real numbers, and the range starts with your asymptote. So this is your asymptote, okay? And so it's y negative 5, and your graph is above that y value. So it's greater than. There's no equal because the graph will never touch an asymptote, and that's basically your asymptote. So let us now go to problem number 2. So here, what is the domain of this graph? Again, there's an arrow to the left and to the right, and so your domain is set of all real numbers. Let us now discuss the range. The range always starts from the asymptote, and so the asymptote is here. As you can see, it's y3. And again, your graph is found above that mark, okay? So it's above that mark. It's never equal because your graph will never touch an asymptote, and 3 is your asymptote. Okay, let's now go to problem number 3. What is the domain? Again, there's an arrow to the left and an arrow to the right. I hope that you're already seeing this. There's a pattern to this. Guys, the domain is always set of all real numbers, even if your graph is growth or even if it's decay. So now let's discuss about the domain. The domain is set of all real numbers. There's an arrow to the left and to the right. The range is always starting from the asymptote. So this is your asymptote right here. It's a 0. So you put the y, this 0, and your graph is found above that mark. See? Above that mark. So that is greater than 0. Cannot be equal because the graph will never touch your asymptote. So let us now go to problem number 4. Let us look at the domain. Again, you mark from the left and to the right, and I see arrows. So your domain is set of all real numbers. As I said, it's like that always. And the range is always starting from your asymptote. So let's check your asymptote is here. That's your asymptote. So y 0. But this time, your graph is found at the bottom of that mark. So because of that, it's less. Okay? Now, it's never equal because the graph will never touch your asymptote. So let's now go to problem number 5. What is the domain? Again, there is an arrow to the left and to the right. So your domain is always set of all real numbers. Or I don't know if they would sometimes put maybe infinity, from negative infinity to positive infinity. Okay? And then your range starts from your asymptote. Asymptote is here. That is y0. Your graph is found above that mark. So that is greater than 0. It's never equal because the graph never touches your asymptote. Okay guys, let's go ahead and do objective number 2. Objective number 2 is I can grab exponential functions that model growth and decay. Guys, this is very easy. This is just graphing and then matching the right graph. So I just want to give maybe one example, maybe 1 or 2 examples of this one. So let's begin. I will just go ahead and graph this. Okay, let's start with letter A. So that's y equals, and then negative 1 divide by 3, but then your 1 has a power of x, so go back to 1 and then press A to the B here, and then put power of x, and then click it on the side, plus 3. So y'all can tell that letter A is not the answer because that's not the same as your graph here. So I will just go proceed to letter C, guys, and the reason why is because this negative right here tells me that your graph should really be going this way, like going down. Okay, so negative is going to flip or reflect your graph. So let's now go to letter C. Okay, so y equals 3, and then a to the b is how you can put your power of x. And then that is a minus 5. And as you can see, it does not match your graph. So that means that it is possibly letter D. By the process of elimination, it's letter D. I plug in letter D and it shows that my y-intercept is here at 0, 3. And I have another critical point here that I'm going to check, and that I think is 1, 5. And it matches. So on this particular example, the answer is letter D. Okay, so let's go ahead and proceed to example number 2. This was the one I was talking about a while ago, where your graph is flipped downwards. Because it's flipped downwards, there was a reflection that happened, and that means that there's a negative sign in the front of your equation. So it's between B and D. However, if you're struggling and could not remember that, there is no harm at plugging them all in and then just matching your graph. So I'm going to go ahead and plug in letter B. So letter B shows this graph. It looks like it, but I'm still going to go ahead and plug in letter D. So the graph of letter A is the blue one. Let me turn that off. And the graph of letter D is this one. So it looks like this is shifted up. So let's turn that off and let's turn on again letter B, and the answer is letter B. Okay, let's go ahead and do objective number 3. I can identify key features of exponential function. So let's go, and it says here, hint. Graph the function and see how it behaves. Letter A, exponential growth with an asymptote of x-axis. You would know if it's growth and decay based off of this one in the inside the parentheses. This is a decay. The reason is because this is less than 1. So everything that says growth, letter A and letter C are already wrong because it's exponential decay. This is not growth. And then once you graph your function, okay, so I graph my function, and it says that it's decay, so it's either B or D, but it says that the asymptote of this one is y-axis and this one is x-axis, and you can tell the asymptote is the x-axis. So the answer here is letter D. Okay, so the next question is actually the same thing. It is asking for you to graph it, and I still have that function here, and it says which one is true about it. So the y-intercept is at 3, y-intercept is none, x-intercept is at 0.4, x-intercept is none, and let's analyze. So here your y-intercept is at 3, so A is right. Guys, there is no x-intercept because your graph is not going to touch the x-axis because the x-axis is your asymptote. Okay, let's do example number 2. So I had graphed this function right here, and it says that the y-intercept is none, y-intercept is at 5, and letter B is right. Again, there is no x-intercept because your x-axis is your asymptote and the graph is not going to touch your asymptote. Next question is the same function, but it's asking for growth and decay. You see this inside number is a 2, that is bigger than 1, so that is growth. Therefore, you have to cross out everything that says decay. So B and D says decay. You just have to concentrate on A and C. And then it says it's growth with an asymptote of y-axis. No, your asymptote here is this. So your asymptote is the x-axis. So your answer here is letter C, exponential growth with an asymptote of the x-axis. Okay guys, our next objective is objective 4. And objective 4 has something to do with all word problems. Okay, so let us, for this objective, analyze number 7 and 8. The Johnson Company calculates the value of its stock each year by using the functions, this one. Is this growth or decay? Look at inside, it's less than 1. Because if it is less than 1, it is decay. The 120 outside is your starting point, or it's what we call the initial value, or also called the y-intercept. I hope you still remember the cancer cells experiment that we did, and we started with 2 there, so 2 was outside. So in this case, your 120 is your initial value or your starting point. Again, this is decay because it's less than 1 inside the parentheses. Your growth or decay factor is 0.98, but the rate is 0.02. Why is 0.02? Because I want you to think about $1. If you have 98 cents, what did you take out of your $1 to make it 98 cents? And yeah, you took out 2 cents. So 0.02 represents your rate. Okay, so let's now go to number 8. Selena's starting salary is $32,000. She calculates her projected salary for the next 5 years by using this equation. So your starting point is 32,000. So that's your initial value. That's where she started with her job salary. This is growth because look at that inside. It's more than $1. So more than 1. So your growth factor is 1.12, but that's not what's going to be asked on the next one. It's going to be what's the rate. The rate is either what you add or subtract from $1. Always start with 1. So in this case, since this is growth, the question is what have you added to $1? And yes, you can tell that it is 12 cents or 0.12, and so that is your rate. Okay, now guys, we're going to move on to objective number 5, and objective number 5 allows you to plug in your equation and then solve for some values of x. So in this case, it says that a house has a cost of $200,000, which appreciates in value 3% each year. So you know that year or time is always your power right here. It's always your exponent. 3% is 0.03. That is what you're gonna add to your $1. Why did you add? Because it says appreciates, not depreciate. So your starting value is 200,000. If you plug this in on decimals, it's gonna look like this. Okay, so as you can see, I plugged it in and it came out the same amount as this one. Also here, look at example number 2. The most recent virus that's making people ill is fast multiplying 1. On the first day of the virus, there are 2 viruses, and each day after the bug triples. So you're going to go ahead and plug in those values. And it says how many bugs are there on the 5th day. And again, 5 is the time. So if you plug all this in, it's going to come out to be 486. Okay, so here I have plugged it in and the answer is the same as this one, 486. I also want to show it to you on the Inspire. So when you graph that, that's going to be... I'm having a different approach on this one. I went to graph and I graphed instead of 5, I graphed X just to show you how this can be done. So you have a graph, but you don't need a graph. You need Control T, and you need to go where it says 5, because it says 5 days, and it tells you the same answer. Okay, so last and final example, you have this equation. Let's go ahead and plug in this next example, the third and last on the graph. That is y equals 2 parentheses 4 caret x. Let's go ahead. So once you plug that in, this is going to be your graph, and you press Control T, and you're looking for when this insect, this is a story about insects that's gonna go above 120, and if it reaches 120, he's gonna be in trouble with his mom. And it tells here that on 3 days, it's gonna be 128. So he's gonna be in trouble in 3 days.